Dividing radical expressions. If the nth root of a and the nth root of b are real numbers, then the nth root of a divided by the nth root of b could be written as the nth root of a over b. So if you're dividing radicals and the root is the same, you can write those as one single fraction under the same radical sign. What is the simplest form of this quotient? So if you have the square root of 18x to the fifth divided by the square root of 2x to the third, you can write those as one single fraction under the same radical sign. Be the square root of 18x to the fifth over 2x to the third. Then just simplify that fraction, 18 over 2, that reduces to 9. And x to the fifth divided by x to the third. Remember, when you're dividing with the same base, the base is x. Subtract the exponents. So that would be x squared. So you're looking at the square root of 9x squared. Square root of 9 is 3, and the square root of x squared would be x. So that simplifies to be 3x. Next, the cube root of 162y to the fifth divided by the cube root of 3y squared. So you're dividing with the same root. You can write those as one single fraction under the same radical sign. It'd be the cube root of 162y to the fifth over 3y squared. Just simplify that fraction. Divide 162 by 3. That is 54. Then y to the fifth divided by y squared. That would be y to the third. Subtract the exponents when you're dividing with the same base. The cube root of 54y to the third. Now 54 is not a perfect cube, but you can break that into two factors where one of the factors is a perfect cube. So think of factors of 54 where one of them is a perfect cube. The best way to break that down is the cube root of 27 and the cube root of 2. And then y to the third, that exponent of 3 is divisible by the root of 3, so that y to the third is a perfect cube. So we're putting all the perfect cubes under one cube root sign, everything else under the other cube root sign. Then the cube root of 27, that is 3, and the cube root of y to the third is y. Just divide the exponent by the root. So that turns out to be 3y times the cube root of 2. Going to divide and simplify the square root of 500 over the square root of 5. You're dividing with the same root. The root is the same square root. So just write those as one single fraction under the same square root sign. It'd be the square root of 500 over 5. Just reduce that fraction. 500 over 5 reduces to 100. So it'd be the square root of 100, and everybody knows the square root of 100 is 10. So that simplifies to be just 10. Square root of 56x to the fifth, y to the fifth, divided by the square root of 7xy. Now once again, you're dividing with the same root. The root is the same, so write those as one single fraction under the same square root sign. So be the square root of 56x to the fifth, y to the fifth, over 7xy. Just simplify that fraction, 56 over 7, that reduces to 8. Then x to the fifth divided by x. When you're dividing with the same base, subtract the exponents. That'd be x to the fourth. And then y to the fifth divided by y. Once again, subtract the exponents. That is y to the fourth. So you have the square root of 8x to the fourth, y to the fourth. Now 8's not a perfect square, but it can be broken down into the square root of 4 and the square root of 2. So we're splitting that 8 into two factors. One of them has a perfect square root, and the other one doesn't break down again. That would be the 4 and 2. Then for the x to the fourth, that's a perfect square because that exponent of 4 is divisible by that root of 2. Same thing with the y to the fourth, that's a perfect square. That exponent of 4 is divisible by that root of 2. So we're putting all the perfect squares under one square root sign, everything else under the other square root sign. The square root of 4 then is 2. Square root of x to the fourth is x squared. Just divide the exponent by the root. And the square root of y to the fourth, that would be y squared. Once again, divide the exponent by the root. So that turns out to be 2x squared y squared times the square root of 2. In order for an expression to be considered simplified, you cannot be left with a radical sign in the denominator, nor can you be left with a fraction under a radical sign. So in this situation, you have 1 over the square root of 2. We need to get rid of that radical sign from the denominator. And to do that, we're going to multiply the top and bottom by something so that that radical sign will disappear from the denominator. Now, what do you multiply by? Well, since you're taking the square root of 2, you want to make that 2 into a perfect square. So you want to think of the next perfect square up from 2 that is a multiple of 2, which would be 4. So how do we get to 4? Well, we're going to multiply the top and bottom by the square root of 2. Whatever you do to the bottom, you also have to do to the top. So if you multiply the top and bottom by the square root of 2, it turns out to be the square root of 2 over the square root of 4. And that radical sign will now disappear from the denominator because the square root of 4 is 2. So that turns out to be the square root of 2 over 2. You've done what's called rationalizing the denominator. You took that irrational number in the denominator and made it into a rational number. So the square root of 2 over 2, radical sign disappeared from the denominator. that is considered simplified. If you have the cube root of x over the cube root of 2. So for the cube root of x over the cube root of 2, once again, that cube root of 2 is an irrational number. So to make that into a rational number, to get rid of the radical sign, you want to multiply that cube root of 2 by something so that the radical sign will disappear. So think of the next perfect cube up from 2 that is a multiple of 2, which would be 8. So how do you get to 8? Well, you multiply the top and bottom by the cube root of 4. So multiply the top and bottom by the cube root of 4. On top is going to be the cube root of 4x, and on the bottom is the cube root of 8. Now the radical sign will disappear because the cube root of 8 is 2. So with the radical sign gone, that is now considered simplified. Turns out to be the cube root of 4x over 2. Again, for something to be considered simplified, you cannot be left with a radical sign in the denominator. Going to rationalize the denominator on the cube root of 5x squared over 12y squared z. One thing you can do is split that into numerator and denominator. You can write that as the cube root of 5x squared over the cube root of 12y squared z. Then you might struggle with figuring out what to multiply by so that you turn that denominator into a perfect cube under the cube root sign. Well, one way to combat that is to do the simple factor trees that you learned in elementary school. Split that 12 into 4 and 3, and then the 4 can be written as 2 squared. And then you still have that multiplied by 3, by y squared, and by z. In order to make that into a perfect cube, each one of those needs to be a perfect cube. So if you have 2 2's right now, multiply by 1 more 2. If you have 1 3, multiply by 2 more 3's. If you have 2 y's, multiply by 1 more y. And if you have 1 z, multiply by 2 more z's. Change each one of those into a perfect cube. So really you would be multiplying by the cube root of 2 times 3 squared times y times z squared, or in other words, multiply the top and bottom by the cube root of 18yz squared. That'll make that denominator into a perfect cube. So if you do that, multiply the top and bottom by the cube root of 18yz squared, that denominator will become the cube root of 216 y to the third, z to the third. That is a perfect cube. Each one of those is a perfect cube. And in the numerator, that just plays along. It's going to be the cube root of 90x squared y z squared. So in the denominator, once again, each one of those is a perfect cube. The cube root of 216, that is 6. The cube root of y to the third is y. And the cube root of z to the third, that is z. So that turns out to be the cube root of 90x squared y z squared all over 6yz. Going to rationalize the denominator, the fourth root of 2 over the fourth root of 5. So we need to get rid of the radical sign from the denominator. Right now you have the fourth root of 5. So if you multiply the top and bottom by the fourth root of 3 more 5's, then you'd have the fourth root of 5 to the fourth, which would just be 5. So that's what we're going to do, is multiply the top and bottom by the fourth root of 3 more 5's, which would be 125. So if you multiply the top and bottom by the fourth root of 125, on top that's going to be the fourth root of 250, and on the bottom that's the fourth root of 625. Remember, that's the fourth root of 5 to the fourth power. If it's the fourth root of 5 to the fourth power, that's just going to be 5. So this turns out to be the fourth root of 250 all over 5. That fourth root of 250 does not simplify. You can't break that into anything that has a perfect fourth root. So that is as far as it goes. We took an irrational number in the denominator, made it into a rational number. We rationalized the denominator and simplified that expression to be the fourth root of 250 all over 5. Next, the square root of 3xy squared over the square root of 5xy to the third. Now before you jump to multiplying the top and bottom by something, think about simplifying or reducing. They're both under the square root sign, so anything is free to cancel. You can cancel the x's off. So if you cancel the x's, you can also cancel the y squared and y to the third. You'd be left with the y in the denominator. So it'd be the square root of 3 over the square root of 5y. Now think of what to multiply the top and bottom by to make that 5y into a perfect square. Well, you have 1 5 there right now, multiply by another 5. If you have 1 y there right now, multiply by 1 more y. So we're multiplying the top and bottom by the square root of 5y. If you do that, on top it's going to be the square root of 15y. And on the bottom, if you multiply the square root of 5y by the square root of 5y, in other words, if you square the square root of 5y, that's just going to be 5y. So it turns out to be the square root of 15y over 5y. Now, a common mistake people make here is they want to cancel the 5y with the 15y. You can't do that. One is under the square root sign, one is not. That is as far as it goes. That is completely simplified. The square root of 15y over 5y. What is the simplest form of the square root of 75x to the fifth over the square root of 12xy squared? Now before you jump to multiplying the top and bottom by something, see if you can't just cancel what's already there since they're both under the square root sign. If you look at the 75 and 12, 3 goes into both of those. Then the x to the 5th and x, you can cancel those. You still have a y squared in the denominator. So with the 75 and 12, as I said, 3 goes into both of those. 3 goes into 75 25 times, and 3 goes into 12 4 times. Then for the x's, you have x to the 5th over x. You can cancel those, be left with x to the 4th in the numerator. And you still have that y squared in the denominator. Now if you look at those, you have perfect squares under the square root sign. The square root of 25 is 5. The square root of x to the 4th is x squared. And the square root of 4 is 2. The square root of y squared would be y. So that simplifies to be 5x squared over 2y. As you see, that is answer G. What is the simplest form of 2 times the cube root of x squared y over the cube root of 4xy squared? Once again, before you jump to multiplying the top and bottom by something, just look to cancel what's already there. The x squared and x, those will cancel, be left with an x on top. Y and y squared, those cancel, you'll be left with a y on the bottom. Now you need to multiply the top and bottom by something so that that radical sign will disappear from the denominator. So you have a 4 in the denominator. We're taking the cube root of that. So we have 2 2's in the denominator, multiplied by 1 more 2, because 2 2's, that is 4. So if you multiply the top and bottom by 1 more 2, that'll make that 4 into an 8, which is a perfect cube. You have 1 y in the denominator, so multiply by 2 more y's. So we're multiplying the top and bottom by the cube root of 2 y squared. Once again, we had 2 2's in the denominator, that's 4, so multiply by another 2, that'll make it into a perfect cube. Same thing for the y. You have 1 y in the denominator, multiply by 2 more y's, that'll make that into a perfect cube as well. So multiplying the top and bottom by the cube root of 2y squared, it turns out to be 2 times the cube root of 2xy squared in the numerator. And in the denominator, that's your perfect cube that you made, the cube root of 8y to the 3rd. So since that's the perfect cube in the denominator, that radical sign will now disappear from the denominator. Turns out to be the cube root of 8y to the 3rd turns out to be 2y. Then you can cancel the 2 with the 2 in the numerator, the 2 that's outside the radical sign. So if you cancel those, that is the cube root of 2xy squared all over y. And that is letter C. What is the simplest form of the cube root of 25xy squared times the cube root of 15x squared? Just multiply those together. 25 times 15, that is 375. X times x squared, that is x to the 3rd. And don't forget you have that y squared as well. So it'd be the cube root of 375, x to the 3rd, y squared. I'm going to split that into 2 factors. Put all the perfect cubes together under one cube root sign, everything else under another cube root sign. So the cube root of 375, I'm going to split that into the cube root of 125 and the cube root of 3. 125 is a perfect cube. For x to the 3rd, that's already a perfect cube because that exponent of 3 is divisible by that root of 3. So put that with the 125. And don't forget the y squared. That's going to go with the 3. So all the perfect cubes are together under one cube root sign. Everything else is under another cube root sign. For that cube root of 125x to the 3rd, the cube root of 125 is 5. The cube root of x to the 3rd is x. So that would be 5x times the cube root of 3y squared. And that is letter A.